Welcome to another episode of Task Mathematics. Today we're going to be looking at operations with fractional exponents. Now our first example, we have x which is raised to the 3 over 7 and I'm multiplying by x raised to the 1 over 7. Now from the laws of exponents, because that's what we're going to use to simplify this, the laws of exponents state that if your bases match, you keep your base and you add your exponents. Now, the only difference between these problems and the ones that I did in previous videos is that your exponent is a fraction. That's it. So you have to know how to add fractions. So I keep my base of x and I'm going to add the 3 over 7 with the 1 over 7. Now, when you're adding fractions and the denominators are the same, you keep your denominator. So I'm going to keep my 7 and I'm going to add my numerators, which is 3 plus 1. So this becomes x raised to the 4 over 7. Now for all the examples I'm going to do today, I'm going to convert any fractional exponents to the radical form, just for practice. So if I have to write the radical form of this, I have my radical sign, my base is x. Remember, your numerator is your power and your denominator is your root. So as I said to my students today, they were getting a little bit confused. I said, focus on one. I usually focus on the root. So I focus on the root. I know it goes here, which means the 4 goes there. So the 7 is here and the 4 is there. Now, again, your base could be a numeral. So you're going to keep your base, which is 2. You're going to add your exponents, which is 3/5 plus 7 over 5. Again, the denominators are the same, so I'm going to keep my 5. I'm going to add the 3 and the 7. So that gives me 2, and that's 10 over 5. Now again, because you have fractions, always check to see if you can simplify. I know that 10 divided by 5 is 2. Now, if you're on the task test and you don't see 2 to the second power, it means you have to evaluate. What is 2 to the second? The answer is 4. Now, sometimes your fractions, the denominators are different, such as this case. I have b raised to the half and I'm multiplying by b raised to the 4/3. The rule is the same. You keep your base and you're going to add your exponents. So I have a half plus 4 over 3. Now, if you can't remember how to add fractions when your denominators are different, this is a little crash course. So this is how I teach it in my college class, because I don't have time to waste, let's say, 30 minutes or an hour on how to add fractions. So I have my fractions. I draw a bar. I call this the smiley face. I'm going to multiply my denominators. 2 times 3 is 6. Then I'm going to multiply diagonally. So 3 times 1 is 3. I'm going to multiply diagonally this way. 2 times 4 is 8. And remember what we're doing? We're adding. 3 plus 8 is 11 over 6. I call it the smiley face. I don't know what's the correct term for it. For me, smiley face. So this will be B 11 over 6. You can use the calculator because remember the task test has 2 parts. You can use the calculator on one section. Remember, this is your calculator function, not your calculator, sorry, your fraction function, which is the n over d. I'm going to enter 1. I'm going to go down, enter 2, go to the right. They want me to add. Again, I need a fraction function. I enter 4. I go down, enter 3, go to the right, and hit enter. Notice I got 11 over 6, which is the same thing when I did my little smiley face method. As before, I'm going to convert this. So since my exponent is a fraction, I'm just going to change it to the radical form, just for practice. So the b is my base, and the 6 is my root. Again, I concentrate on one thing. I concentrate on the root. The 6 is the root, which means the 11 is my power. Now, suppose we're dividing. Now, if you're dividing and your bases match, you keep your base and you subtract your exponents. So this is 3 over 4, take away 1 over 4. Now, this is simple because the denominators are the same. So I'm going to keep that 4, and I just have to go 3 minus 1. So this is b raised to the 2 over 4. Again, if you have a fraction, check to see if you can reduce. I know that 2 and 4 can be divided by 2. So this is b raised to the half. Now, if I have to write this in the radical form, my base is b. Now, my root is 2. I don't have to indicate it, and my power is 1, so I don't have to indicate. I'm going to write it here. So whenever your root is 2 and your power is a 1, you do not need to write it. Your answer is just radical b, or square root b. Here, my base is a numeral, so keep your base, and we're going to subtract 5 over 8 minus 7 over 8. So again, the denominators are the same, so I'm going to keep the 8. And I'm going to do 5 minus 7. Now I know 5 minus 7 is negative 2 over 8. And again, we're working with fractions. Can I simplify this? The answer is yes. I can divide both of these by 2. So this is 3 raised to the negative 1 over 4. Now if you're on the task test and you don't see 3 raised to the negative 1 over 4, then you have to change this from the negative to the positive, which would be 1 over 3 raised to the positive 1 over 4. Now, when you change this from the negative to the positive, you're not changing your fraction. That fraction just changes from a negative to a positive. Now, if you don't see this 1 over 3 raised to the 1/4, then you're looking for its radical version, which is 1 over, I'm going to put my radical sign, there's my 3, my root is 4, which goes here, and my power is 1, so I don't need to write it. So if you're on the test, this is your first answer. If you don't see it, change the negative exponent to a positive form. If you don't see this, then you need to change from the fractional exponent to the radical form. Lastly, I have y 3 over 2, and I'm dividing by y raised to the 1/3. So the rule states, keep your base, subtract your exponents. So that's 3 over 2, take away 1/3. If I do my little smiley face, 3 over 2 minus 1 over 3, I draw my line. 2 times 3 is 6. 3 times 3 is 9. Minus 2 times 2 is 2. 9 minus 2 is 7 over 6. So this is y 7 over 6. If you want to, you can use the calculator. I'm not going to use the calculator. So we already did it. You can practice on your own. Now here I have a base raised to an exponent and raised to another exponent. Remember, this is our power rule. So the power rule states if you have a base raised to an exponent and raised to another exponent, you keep your base and you're going to multiply your exponent. So that's 2/3 times 6. Now I'm going to make 6 a fraction. I'm going to put it over 1. Now, when you're multiplying fractions, this is the only time you actually do what it says. You're going to multiply. So you're going to multiply straight across. So this will be 2 times 6 over 3 times 1. My base is a. 2 times 6 is 12 over 3 times 1 is 3. Now I know that 12 can be divided by 3, so that will be 4. Since my exponent is an integer, I don't need to change it to the radical form, so that's my answer. Again, I have b raised to the 3rd, and all of that is raised to the 2/5. The rule states you keep your base, and you're going to multiply your exponents, so that's 1/3 times 2/5. Again, when you go straight across, 1 times 2 is 2. 3 times 5 is 15. Now, can you simplify 2 over 15? The answer is no. It's already in simplified form. However, I can write the radical. So here's my a. The 15 is my root. So that goes there, which means the 2 is my power. If you want to use the calculator, again, press the fraction function into your 3rd, down 3 to the right. You're multiplying, fraction again, 2 down, 5 to the right, and hit enter, and there you got 2 over 15. That wasn't so difficult. Now, sometimes on the task test, you have to actually simplify. Now, notice this is written in the radical form. I have the cube root of x to the 7th, and I'm multiplying by the square root of x to the 5th. Now, our brains are not programmed to actually simplify this as is. So your first step is to take it from the radical form to the exponent form. So this will be x raised to the 7 over 3. Remember, 3 is your root, so it's your denominator. And I'm multiplying by x raised to the, now I don't see a number for my root, which means it has to be 2. And the 5 is my power. Now the bases match, so I would keep my base and I'm going to add my exponents. So that's 7 over 3 plus 5 over 2. So again, if you did my little smiley face trick, 7 over 3 plus 5 over 2, I draw my line. 2 times 3 is 6. 2 times 7 is 14. Plus 3 times 5 is 15. If I add 14 and 15, I get 29 over 6. So this is x raised to the 29 over 6. And if I change it, because sometimes on the task test, they'll give you this, you convert everything to the exponent form, but their answers are in radicals. So when you get here, you have to take it back to the radical form. So my base is x, my root is 6, which is here. So my 29 is my power. Sometimes they mix and match. So here I have the radical form and here I have the exponent form. And in order to evaluate or simplify this, again, make everyone exponent form. So this would be x raised to the 5 over 3. And I'm multiplying by x raised to the 1 over 5. So the rule states when the bases match, you keep your base and you're going to take 5 over 3 and add it to 1 over 5. If we use our calculator for this one, if I clear that, we have 5, oops, clear, it's clear. Fraction function, 5 over 3. Go across, I'm adding, okay, let's see what we're adding, 1/5. Fraction function again, 1 down 5 to the right, enter. I get 28 over 15. So this is x 28 over 15. If you want to do the smiley face method, you have 5 over 3 plus 1 over 5. Okay, let's start our smile. 3 times 5 is 15. 5 times 5 is 25. 3 times 1 is 3. And there's our 28 over 15. Now that can't be reduced anymore, but we can write this in the radical form. So there's my x. My root is 15. My power is 28. Now, what would this look like on the task test? So I have 2 examples here. So right here, we want to simplify. Now, I did something like this today in my class. Now, if I want to simplify this and I am on the, let's say, non-calculator section, so they want me to find the square root of 6 to the 4. Again, our brains are not made to evaluate this. So I'm going to change it from the radical form to the exponent form. So this is 6 raised to the 4 over 2. Because I don't see a number there, the root is 2. Now, 4 divided by 2 is 2. And 6 to the second, now notice I have 6 to the second power, but I look at my answer choices, I don't see that. So again, I have to evaluate it. 6 to the second is 36. So my answer is D. The second example says which expression below is equivalent to the cube root of x to the 5th times the 4th root of x to the 3rd. So again, we first have to change this from the radical form to the exponent form. So that would be x 5 over 3 that you're multiplying with x 3 over 4. When the bases match, you keep your base and you're going to add 5 over 3 plus 3 over 4. Now, where I took this question, it said I could use the calculator. So I'm going to bring out my calculator and I'm going to put in 5. Actually, let's clear that. Fraction function first. 5 down 3. Go to the right. I'm going to add fraction function 3 down 4 to the right, and I hit enter and I get 29 over 12. So this is x raised to the 29 over 12. Now notice our problem was given in the radical form, but all our answers are in the exponent form. Notice I go between the words exponent and fractional, so that is the same thing. So my answer would be A. Let's choose red, make it nicer. So my answer is A for this one and D for this one. So these are just two examples of what these questions may look like on the task test. I hope this has been helpful. Good luck on your task examination.